Okay, this is Mr. Smith. We're looking at section 6.6, solving radical equations. Again, mathematics and algebra, we concern ourselves with solving equations. In this section, we are going to work on solving radical ones. So when we say a radical equation, we mean something like this guy where we have the cube root of 2x plus 7 equals 3. Okay, so this is a radical equation. And so our process for solving these is to, step one, isolate the radical. Okay? So we need to get one of the sides to only have the radical piece on it. Whatever's on the other side we don't care about. We need to get one side that only has the radical. Step two, we're going to raise each side of the equation to the same power to eliminate the radical. What they mean there is if I'm taking a square root, I'm going to square both sides. If I'm taking a cube root, I'm going to cube both sides. Okay. So we're going to raise each side to eliminate the radical. And whenever I do to one side, I have to do the other. So if I cube one side to get rid of a cube root, I have to cube the other side. And lastly, we're going to solve the resulting equation. And the resulting equation may not be nice. The resulting equation may not be nice. It may be linear, and in our first examples it will be. By the time we finish today's lecture, they'll be quadratic, but there's no guarantee on what type of equation we're going to get, and there's no guarantee that it'll be nice. We may need to use a quadratic formula. It could be that we get a cubic equation and we have to do that long division thing. Oh, yeah. So these problems can get difficult. Oh, by the way, remember that idea of extraneous solutions? That's also going to come back in to play. Okay, so here's our approach. Let's get an example under our belt. So here we have the cube root of 2x plus 7. The cube root of 2x plus 7 equals 3. Okay. So let me rewrite it. So how do I undo a cube root? Cube both sides. So we cube here, and we cube here. And if I cube a cube root, I'm left with 2x plus 7 equals 27. It's pretty nice. Just a linear equation now. I subtract 7, 2x equals 20, x equals 10. I think relatively straightforward from the math that we've been building on. Okay. Again, if you want to check this to verify that it really does work, we plug 10 back into the original equation. 2 times 10 is 20, plus 7 is 27. Cube root of 27 is 3. Okay. Let's take a look at another problem. Cube root of x minus 5 plus 1 equals negative 1. So when we come back to our procedure, the process says the first thing we need to do is get the radical by itself. We want to get the radical by itself. So to do that, we will subtract 1 on both sides. So this gives us the cube root of x minus 5 equals negative 2. At this point, we cube both sides. This gives us x minus 5 on the left side equals negative 8 on the right side. Add 5 to both sides. X equals negative 3. Okay. Okay. We're looking at another problem. I've erased the original one that was there. I didn't like it. And now that I think about it, I need to modify it again slightly. So let me change this to 8. Trust me, it'll make our lives a little nicer. So the problem I want you to solve is 3x plus 4 to the 3 halves power equals 8. So the question becomes, in the previous problem I had a cube root, and so to undo it, I cubed both sides. Now I have a 3 halves power. How do I undo that? Right, I'm taking this thing to the 3 halves power, and I want to undo that. So I want to raise it to some power. I want to raise both sides to some power. So here we have the original, 3x plus 4 to the 3 halves. And I want to take this to some power so that basically the powers cancel each other out. They negate each other. And so the power that I want to take both sides to is the 2/3 power. Okay, basically, whatever this is, we want to take the reciprocal power. Okay, and in fact, that's actually what we did before, right? If you think about the cube root is the 1/3 power, so I took the reciprocal power, the third power, and I used that. Okay, well, that's exactly what we do here. I have the 3 halves power, so I'm going to use the reciprocal power, the 2/3 power. Okay. And so again, on the right-hand side, these powers are going to multiply to give me 1, basically eliminating that part of the problem. And now I need to address what is 8 to the 2/3 power. Okay, so 8 to the 2/3 power is the cube root of 8, which is 2, squared, which is 4. Minus 4 on both sides, 3x equals 0, and x equals 0. And that's the solution to this equation. Okay, so the idea is whatever power I have on one side, I raise both sides to the reciprocal power. I raise both sides to the reciprocal power, and that allows me to cancel out the powers. Okay. Here are a few problems, and I'd like you to ignore questions 9 and 10 and simply try question number 8. Okay, so if you're watching at home, please ignore questions 9 and 10 and focus on question number 8. Okay? Okay. So we need to take both sides to some power. The power should be the reciprocal power, so the 2/5 power. And whatever I do to one side, I must do to the other. So this gives us x plus 3. Right, 5 halves to the 2/5, those cancel out. And now I'm left with 32 to 2/5 power. Okay, well, the 5th root of 32 is 2, and 2 squared is just 4. So 32 to the 2/5 power should just be 4. Again, your calculator will assist you there, but you still should know how to be able to do that. And now I'll subtract the 3, and x equals 1. So when we solve this equation, x equals 1. All right? So as we proceed farther into this section, we're going to start to see some more difficult problems. And with those difficult problems are going to come extraneous solutions. Just as a reminder, these are solutions that you obtain from doing all of the right steps, but they don't actually work to the original equation. Okay? So, here we are. X minus 2 equals the square root of x plus 10. Square root of x plus 10. So I need to undo a square root. Remember, step 1 is to isolate it. Well, it is isolated. There's nothing else over here with it. So how do I get rid of a square root? We square both sides. Square both sides. So, if I square both sides, let me rewrite this. X minus 2 squared equals the square root of x plus 10 squared. And so the right-hand side, we're just left with x plus 10 because the square root and the square cancel each other out. And on the left-hand side, what's that? X squared plus 4? No way. At this point in the year, we can no longer be making a mistake, and I would assume probably maybe a third to maybe even a half of my students would look at this and consider possibly writing x squared plus 4. That's not how we square a binomial. Right? We square a binomial by foiling this out. That is to say, x minus 2 squared is x minus 2, x minus 2, and when we multiply that out, we should get x squared minus 4x plus 4. Okay. Right, we've got to know that. We've got to be on top of that now. This is a quadratic equation. The question now is, how do I solve quadratic equations? So we have several methods at our disposal. I'm going to set everything equal to 0. So x squared minus 5x minus 6 equals 0. At this point, we could use the quadratic formula, or this also happens to factor. So let's factor it. So how about x minus 6, x plus 1 equals 0? I believe that'll work for us. And now that implies that x equals 6 or x equals negative 1. So let's check those. If I plug in x equals 6, I get 6 minus 2 is 4. So the left-hand side says 4. And here I get 6 plus 10, which is 16. The square root of 16 is just 4. Check. That works. If I plug in negative 1, I get negative 3 over here. And negative 1 plus 10 is 9. Square root of 9 is positive 3. So I get negative 3 on one side equals positive 3 on the other side. And so this solution is extraneous. Solution is extraneous. Okay? All right, let us try one more problem. Let's try one more problem here today. And we'll call it a day for now. Okay. So again, it's very similar to the last one. I have a square root on one side. I want to get rid of the square root. The way that I do that is by squaring both sides. So on the left-hand side, I have 21x plus 1 squared equals x plus 5 squared. So on the left-hand side, we're left with 21x plus 1. On the right-hand side, again, x plus 5 squared means I have to FOIL that out. That's going to give us x squared plus 10x plus 25. Again, this is a quadratic equation. I'm going to set everything equal to 0. So 0 equals x squared minus the 21x should give us minus 11x. Minus the 1 should give us plus 24. Okay, just set everything equal to 0. And this, again, looks like it should factor. So if we factor this, I think x minus 8 and x minus 3 looks like it'll work for us. And so that means, and again, if this doesn't factor, that's fine. We can always use the quadratic formula. And so now x equals 8 and x equals 3. And again, now that we're on to the second part of the second part of the section, we need to check these problems to make sure there aren't any extraneous solutions. So we plug them in. If I plug in 3, and remember we want to start at the original equation, that gives me 8 on this side. Here, 3 will give me 63 plus 1 is 64. Square root of 64 is 8. So this is good. So when I plugged in 3, I was fine. Okay. Now let's do 8 on both sides. So 8 plus 5, is 13. 21 times 8 is 168. Plus 1 more is 169. Square root of 169 is also 13. So this also works. So in this problem, both of these solutions do work, but that won't always necessarily happen. That's why we need to check for them. Okay. So at this point, let us conclude for today, other than letting me show you what tomorrow's problem looks like. Okay. Okay, so this is where we're going to go into the future. I see there are square roots on both sides. All right, square roots on both sides, and so we're going to implement a similar process to be able to solve this. Thanks for your attention. Have a great day. Please silence your cell phones.